saltstack is a configuration management tool. Shortly, it is called as Salt. It's basically written in Python. Okay, it is a well-written Python-based configuration management and then a orchestration system. Okay, so Salt also provides you option to manage the virtual machines. Okay, it can be a cloud or physical missions as well, and it can relay the configuration files to the various servers. Okay, so Salt uses a master client model. Okay, so in which you will have a dedicated master, and then Salt minions will be available on the nodes. Okay, it uses the push model for execution command, and this execution basically works on the SSH protocol. Okay, so the master will communicate to the minion via the SSH protocol, and there are specific port numbers which will be used for the communication and through which things will happen. Okay, and then the communication between the master and minion uses the 0MQ setup. So basically, it's a pops up model where the instruction will be written on the 0MQ, and then it will be passed on to the nodes to achieve that. Okay, so the instructions are written in YAML format. Okay, or you can also directly write a Python code, and then Jinja is used for the templating perspective, where you want to have a dynamic template to be available, then you can write it in the Jinja configuration. Okay, so what is the features of the Salt stack? Okay, so by default in the design, Salt is the fault tolerant model. That means, so a single minion can be asked to communicate to multiple masters, so that if in case there is an issue with the one particular master, the other master can provide the configuration. So it will be easy to have a high availability, easy to achieve a high availability in the Salt scenario. So the first scenario you are going to get is the fault tolerance mechanism. And next is the flexibility coming into it. Okay, so Salt can be managed in multiple topologies. Like it can either say that, okay, you work in a master slave architecture model where you have a Salt master, and then you have a agent available, they communicate to that. That is one kind of topology. Or you can configure Salt to have agent only topology. I don't want the master, I want only the agent to be installed, and for the agent I can directly give the instruction in the state files, and that can be also achieved. Or it can be, you can configure it like it is going to like on the same machine you are going to have the Salt master, and the Salt master can manage on its own. Okay, so this is on the flexibility part. You choose what is the topology I want to use for it. Okay, and next advantage or feature in the Salt is called Salt is very lightweight. Okay, so the design is like on a single master you can manage up to 10,000 minions. Okay, so this is not at all possible in a Puppet or a Chef scenario. Okay, because you need a higher capacity missions, and the maximum you can go up to like 4,000, 5,000 nodes, but Salt can handle 10,000 minions per master. That is the design that has been done. So it is very scalable configuration management tool. Okay, and then next is Salt supports execution of the Salt state in a parallel configuration. So let's say you are having a state execution which takes like a 1 hour or 2 hour. If you want to speed up, you can execute the state in a parallel scenario so that you can achieve the things faster. Okay, and then Salt provides a API. Okay, you don't need to control the Salt manually using the CLI or anything, and it also provides the API. Using the API, you will be able to trigger all the Salt actions. It will be easy to manage, and then it is easy to set up because you are going to have one master, and in that, from there you can control all the nodes which are connected to it. So this is the